Yeah, okay, 720 is better. So we'll just do that.
Yeah, that's fine.
Yeah, so I was thinking, as far as the structure of the conversation, I can briefly present the fine tuning argument. I mean, I think people will know it, the gist of it, so
Yeah.
I can keep that relatively short. I anticipate that the conversation is going to be pretty technical, just by the nature of the case, and I'm okay with that. We won't get as wide a viewership just because we're talking about the details of probability theory. But I found it very
Right.
interesting thinking about your argument, and I'd just rather have that conversation at that level. And whoever wants to listen, great. Whoever doesn't and finds it mind-numbingly boring, that's okay. So that's what I kind of think is I'll present the argument and then you can present your objection, which is really an anti-design argument in itself, and then we can discuss that.
Sounds good.
Right. So let me full screen here. Cool. So the fine-tuning argument is just essentially the claim that fine-tuning is evidence for theism over naturalism in its most modest form. So fine-tuning refers to a discovery of modern physics and cosmology that certain features of the laws of physics are such that if you altered their values even slightly, it would be impossible for life to evolve and exist anywhere in the universe. So the most stark illustration of this is if you change what the value of what's called the cosmological constant. It's a constant, a number that appears in Einstein's equations of general relativity. So if you made this magnitude slightly larger, the universe would have recollapsed in on itself shortly after the Big Bang. And obviously, you can't get life in a universe like that. If, however, you make the value of that constant slightly smaller, then the universe expands so rapidly that gravity has no time to bring galaxies together, and therefore there's no chance for life to evolve. There's not enough time for life to evolve before matter is just thrown apart rapidly. And there's no complex structure in a universe like that. So that's just one example of fine-tuning, that the value of this constant has to fall within a very narrow range compared to the range of ostensibly possible values that it could have had. The range of possible values is huge compared to the life permitting range. And there are lots of examples of this kind of fine-tuning. So then the question naturally becomes, well, why do these constants and features and values of physics take on values in the life permitting range? And the argument that the fine-tuning advocate gives is that if God exists, there is an all-good, all-knowing, and all-powerful designer of the universe. It's not at all unlikely that such a designer would want the universe to be life-permitting, and so would design the laws of physics such that the constants would have these values so that it can allow for life. Life is a great good, and conscious agents within the universe allow for all sorts of goods that would not otherwise be possible. And so it's not that unlikely that we should have fine-tuning if God exists. By contrast, if naturalism is true, if the natural world is all there is, then there's no reason at all why the values of the constants would fall in the life-permitting range as opposed to anywhere else in this huge range. And so the likelihood of fine-tuning, the likelihood of the constants falling in the life-permitting range is just the size of that range over the life-permitting range. And because the life-permitting range is so huge, and the possible range is so huge and the life-permitting range is so small, the likelihood of the constants being life-permitting given naturalism is extremely small. And to illustrate what I mean by small, the physicist Luke Barnes has estimated that given this approach to determining the relevant likelihoods under naturalism, the likelihood of the constants being life-permitting is 1 part in 10 to the 136th power. So that would be 1 part in 10 followed by 136 zeros. It's very, 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 very small. So then, given the fact that we do have fine-tuning, that obviously it's undeniable the universe is life-permitting and the constants have these remarkable features, it follows that fact is strong evidence for theism over naturalism. So that's the fine-tuning argument in a nutshell. And what we're going to debate then is Troy's objection to this argument, which is very interesting. It's on the surface anyway. What is fascinating about his argument is that it seems like a good one. I could not immediately figure out what was wrong with it. And so that makes it fun to discuss. So go ahead, Troy, do your best to refute the fine-tuning argument.
Very good. Yeah. I just want to make a couple of remarks at the outset. Oftentimes there's different sorts of fine-tuning arguments, and my critique is really just concerned with a kind of strict Bayesian formulation, which is more or less what you gave. But do note, and I'm sure you're aware, that oftentimes it's framed like abductively as well. Like, what's the best explanation? Where
Mm.
the considerations there are not merely or even uh, at all the probabilities involved. So you might think it's just a better explanation, even if it's not based on or based entirely on the fact that it's more likely given that data or something like that, if that makes sense. Um, that's something that can be talked about, but that's not what my critique focuses on. Um, so yeah, I was thinking I could give my basic counter argument first. There's a sort of other
Hmm.
argument that I have that's related. Um, that it's I want to see what your thoughts on that too. Um,
Sure.
I, a few days ago I talked with uh, Matthew Edelstein for Joe's channel where I went through all this stuff and he took by my lights an interesting approach in response, but we could maybe
Okay.
get into some of that. Um, yeah, so just to set up I frame my point, my critique as a kind of counter argument, as you said, and just at the outset, I want to state two hypotheses to consider. Right, one is the what I call bare design hypothesis. Um, I could call that D. I guess I don't have slides here. I guess I could, but I could use some of the same slides I used. But
I know I was
um,
going to say that's the one thing inhibiting us is that we're going to be referring to equations and inequalities and
so
variables. And
I
so
do
we'll
have
see what I
slides
can do in the
because
editing stage.
I do have slides that I
Oh,
can
okay.
send you. Okay, so yeah, right now I'm just on slide 6 or 7, just pointing out the kind of bare hypotheses, right? Uh, so I have bare design, which I call D, and
Mm.
that theory just says that there's exactly one universe, and it was designed. And then I have bare non-design, which is N, which says that there's exactly one universe, and it was not designed. Note at the outset, I'm just comparing single universe models. There's obviously relatively extensive literature on uh, the multiverse, and then objections to that. This universe reply, the inverse capitalist fallacy objection. We could talk about that, but I'm just sort of leaving that to the side for now and just granting that, or at least for the sake of discussion, comparing the single universe models. One says it's designed and one says it was not. And then, yeah, L is going to stand for the data that there are life permitting conditions. Yeah, and so with that in mind, I have a argument here. I'll give it in sort of natural language first, and then you can show the more formal representation of it. And really, all the work is being done by the first two premises here.
Right.
Really, more or
Right.
less the second premise. And objections I expect to get, that I have gotten, I've gotten a bunch of different objections, are going to be targeting primarily the second one, although some people have issues with the first one as well. Anyway, the first premise says the prior probability of D, right, the Bayer design hypothesis from before, is not greater than the prior probability of N. Right, so it's before considering the data about what the universe is like, or especially the fact that L, um, we shouldn't consider it more likely that it's a single universe that was designed than that it's a single universe that was not designed. Okay, we can come back to that. But then the second premise says the probability that L, right, the probability that there will be life permitting conditions, conditional on D, that is the Bayer design hypothesis, is not greater than L conditional on N, right? In other words, the Bayer design hypothesis does not more strongly predict that there will be life permitting conditions than does the Bayer non design hypothesis. And the basic idea here is that because these are what I'm calling the bare hypotheses, they don't really say anything about what sort of designer it is, what sort of thing it was designed, or what sort of universe obtained, uh, given the theory. And so, yeah, you should think that more or less any world that might have been designed might have been not designed, and the theory doesn't give us a reason to sort of bias the expectation towards one uh, sort of universe over others, if that makes sense. But of course, that's going to be controversial, and I assume we'll come back to that. Um, yeah, and then from there, the third premise just says, well, any more substantive design hypothesis is not more probable than D when both are conditioned on the data that L. Um, this is just a kind of theorem of probability, because you can say, in other words, it's like saying the probability that A and B given C is not greater than the probability of just A given C, right?
Right.
The probability of a conjunction conditional on some data is not greater than the probability of just one of the conjuncts conditional on the same data.
Right.
And that, since I'm modeling a more specific design hypothesis as D and some further commitments, right? You can sort of always model it that way. We can say the same thing there, right? The probability that that more specific design hypothesis, say D and Q is true, is not conditional on some data, say L, is not greater than the probability of the bare design hypothesis conditional on that same data. Okay. And then premise 4, D is not more probable than N when both are conditioned on the data that L. This sort of straightforwardly follows from 1 and 2 by just applying Bayes' rule. I could walk through that. But, and then premise 5 so says that any more substantive design hypothesis is not more probable than N when both are conditioned on the data that L. And it's sort of easier to see this if you see the more formal expression of the argument. But premise 5 here just follows from 3 and 4, but from the transitivity of the less than or equal to relation, right? You get, well, I assume we'll have it on the screen at some point, and you can see how that follows. And then premise 6 just asserts that L, right? That's their data, that there's life permitting conditions. And so it follows premise 7 that our posterior on D or any more substantive design hypothesis is not greater than our posterior on N. Or in other words, although it might be the case that L confirms or maybe even strongly confirms some design hypothesis, especially more specific ones that more strongly predict it, it's not going to confirm them to the degree that they're more likely than the bare non-design alternative. And if you think about what this argument is saying, effectively, I allow that that bare non-design very weakly predicts the data. The very weakly predicts L. Maybe it is 1 in 10 to the 136. But the thought is that you get something similar on design, and you might have more substantive design hypotheses, like what Luke Barnes talks about there being a loving designer, or people talk about perfect being theism, or something else along these lines. You don't have to add in a whole lot, right, to have a more substantive design hypothesis. And the idea is that, okay, you can have that hypothesis that more strongly predicts L, and indeed you could have one that entails L, but the thought is that if my constraints are right, and we can discuss sort of more motivation for thinking that these constraints are reasonable, the theory in question is going to take a corresponding hit to its prior, right, such that the posterior is not going to favor it. It's not going to be favored to N conditional on the same data. So that's the basic argument. If you want to give a sort of initial thoughts, and then we can discuss more some like motivation and so on.
I think the important point to make is that it's going to be hard to follow the logic of that unless you've looked at it really carefully and thought through the logic of probability. But I do think it is the case that if you grant those first two premises, everything else follows from just deductively, given the relevant logic in place. And so it will come down to whether or not we grant 1 and 2. And I'm also willing to grant 1, that our initial credence or degree of belief in design, bare non-design and bare design, let's just say for the sake of argument, is 50-50. And that at the very least, that design is not going to be much greater than non-design. So for me, it comes down to the second premise. And that's the one I'll ultimately reject. But I guess first I'll want to hear what your reasons are for thinking that it's true.
Yeah. So just a quick remark on the first premise as well. I actually think that premise is going to be overly charitable, actually. And this may come back when if we have reason for thinking that design, like conceptually, is loaded in a way which to some degree, even very modestly, predicts L, like in a way that N does not. I think, I mean, I don't think that's correct, but I think we can substitute it for an even weaker sense, something like cause or correlate with or non-causally explain or something like that. And we can come back to that, but just as a
Mhm.
brief aside. And also, if we think that one is false, because, well, maybe you think that design is antecedently much more probable uh, than than non-design. Well, that's not credence that I would share. However, if you grant the rest of the argument, like the fact that the posterior on design is going to be higher than, or maybe even much higher than non-design, is really just coming from those priors, right? So really, it doesn't help the proponent of fine tuning all that much to just reject one. Really, they have to reject two,
Right.
even if they
I
reject
agree.
them as well. So yeah, yeah. I mean, the basic idea in support of two is what I said before, which is that, look, if you think about what a like, I want to think about, okay, how what does the theory predict about what the universe is like? And my thinking is that, well, if we just say it was designed, that tells us nothing about what sort of designer it is, nothing about what sort of creative dispositions it would have or realize, nothing about what sort of universe there would be, more or less, right? Um, Now, in the same way, I want to say that's just like the same thing you got on the other side with the non-design hypothesis. It tells us nothing about what sort of universe there would be. Um, and I don't see a reason, like, just based on comparing the theories like that, like, why would the design one be such that the expectation for what sort of universe there would be is even moderately biased in one way that the other one isn't? It seems like, as far as what sort of universe would you expect conditional on the design hypothesis, bare design, it's more or less the same as what we'd expect conditional on non-design, bare non-design. Now, I assume we'll get into more considerations about theory comparison and simplicity and so on, and how to relate simplicity and priors. But just at the outset, and I don't suppose that there's some, I don't know, right way to think about uh, assigning priors and conditional probabilities like this, especially when we're dealing with cases that are, well, not as sort of tightly constrained as some like common everyday toy examples. Um, so but in any case, though, this seems like the way roughly to approach it to me. And more can be said about this. But yeah, the basic idea is that the two hypotheses more or less are similarly informative about what sort of universe there would be. And so, if since they're similarly informative about what sort of universe there would be, uh, we shouldn't expect that it's more likely, let alone much more likely, on one of them that there'd be life-threatening conditions than on the other. That's the basic idea.
Yeah, so I think in a certain sense that's correct. That if we have absolutely no relevant information to go on, nothing is specified about the designer in question. If both those conditions obtain, well, then the likelihood of fine tuning given the bare design hypothesis will just equal the likelihood given naturalism, or what we're calling the bare non design hypothesis. Because in either case, you would just apply a principle of indifference to all of the values of the constants and quantities. The exact same reasoning that you would appeal to show that fine tuning has a low likelihood given naturalism, you would also just appeal to show that fine tuning has a low likelihood given bare design. It's a little more nuanced because in this case, bare design is a huge disjunction of sub hypotheses, and you would because you have to realize that some of those sub hypotheses will give a huge likelihood to design. Say the hypothesis that the designer is crazy about having life permitting universes. Well, given that hypothesis, fine tuning has a huge likelihood, but it's exactly the contribution of that likelihood of the sub hypothesis to the likelihood of the disjunction as a whole is just canceled out by other sub hypotheses which have an incredibly small likelihood to fine tuning. We could even just build in a hypothesis: the designer hates life permitting universes such that the likelihood that they would ever design a life permitting universe is less than 1 part in 10 to the 136th power. So the general point isn't that hard to see when you stay at a broad level, that the likelihoods from those sub hypotheses will have corresponding hypotheses that just cancel out, and you result in an epistemic situation which is no different than what we encounter when looking at fine tuning given naturalism. You don't change the probability distribution at all. You'll just have that same condition, that the likelihood of fine tuning given bare design is 1 part in 10 to the 136th power. So
just quickly,
go ahead.
But I'll let you get to your point in a second, but just it's compatible with that, of course, that the data is pretty good evidence for some of these more specific design hypotheses, in the sense that, maybe their prior was extremely low, maybe even much less than 10 to the negative 36, 136 or whatever. But after updating on L, maybe it's quite high. Maybe it's, less than, well, it's going to be less than 50% if my argument is correct, but it's not going to be, say, many orders of magnitude below 1, perhaps. So it might still be good evidence for them in the sense that it raises their probability, but it's not going to be evidence for them that favors them to non-design. That's my argument.
Yes, that's a good point. And so I think the only other point to make explicit that I failed to do so before is that in this case, we're applying a principle of indifference to all of the sub-design hypotheses. And that's how we get the same probability distribution in the end of fine-tuning given bare design, is because implicitly anyway, we're saying that all of these sub-design hypotheses are equally likely, right?
So I wouldn't want to commit to something that strong. In fact, I wouldn't say that all the sub-design hypotheses are equally likely, because after all, you can have more or less specific sub-design hypotheses, and we can talk about how I want to convert something like specificity or complexity in this way to priors. But like, if we're comparing at the level of like possible worlds, so to speak, right? If we can try to sort of apply indifference across that space, although we went into, normalizability concerns, blah, blah, whatever, then yeah, that seems more or less fair. I mean, but that's not to say that every more specific or sub-design hypothesis is of equal likelihood, or that we can imply difference across them, because I actually wouldn't want to do that, because you can have, note that, of course, you can have sort of nested specificity, right? So I can have a more specific design hypothesis and one that's strictly more specific than that, right? And obviously I want to say that I'm not indifferent between those two. The relatively less specific one should be antecedently more likely. But if we're comparing sort of maximally specific design theories, in the sense that they pick out which sort of possible world is the one that the theory says is actual, most theories aren't like this. They don't specify an actual specific world. Then yeah, we can think in a sort of idealized way about applying indifference across those. I don't, as a matter of approaching this, assume that we're applying indifference in some strict way. I know there's issues in the principle of difference. Maybe they're surmountable, but I don't really require taking a strict stance on that, or applying that to my case here. But yeah, that's a further discussion, perhaps.
Yeah, I think that's a good point. I just, there does seem to be a step here, though, in the reasoning of getting to the conclusion that fine tuning is no more likely on bare design than design, by which we appeal to some sort of symmetry and therefore equal likelihood between those sub-design hypotheses which favor design and fine-tuning, and those which do not favor fine-tuning. And so when you take the weighted average of all of the likelihoods of the sub-hypotheses, you're going to end up in a situation where the likelihood of the whole disjunction of bare design is the same as the likelihood given non-design.
Yeah, but my that's right. But my point is that we can do that. You can have that without assuming strong sort of indifference principle. So like, maybe we think that the distribution across specific design hypotheses is not flat, right? Maybe it's interesting in some ways, but you might think that it's interesting in those same sort of ways across the others, the corresponding non-design space. But so the point is that you get, it sort of comes out in the wash, even if we're not assuming a uniform prior in both cases.
Okay.
But it's a slightly technical point, but not worth getting into all that much right now, I think.
Okay. So let me give you my response, and it's somewhat lengthy. I actually have 2 points here, but I'll give one. So let me ramble through the whole thing, and then I will get your response, if that sounds good. So again, this is going to get technical, but that's philosophy. That's where we're at. So here's what I said. So I think that if 2 conditions obtain, it will follow that premise 2 of your argument is false. And I think those 2 conditions are plausible. And so I think it's plausible that the second premise of your argument is false. So if 1, the first condition, life-inclined designers, those sub-hypotheses of the bare design hypothesis, according to which a designer would be inclined to create a universe with life, if life-inclined designers, LID hypotheses, take up a non-negligible proportion of the probability space under the bare design hypothesis, and if 2, the second condition, the likelihood of fine-tuning given life-inclined designers is non-negligible, then premise 2 of your original argument is false. It is not the case that the likelihood of fine-tuning given bare design is less than or equal to the likelihood of fine-tuning given bare non-design. Rather, it will be the case that the likelihood of fine-tuning given bare design is greater than the likelihood of fine-tuning given non-design. So consider just a simplified illustration of this implication if those 2 conditions are granted. Let's say that the prior probability of life-inclined designers is 1 in a million, and the likelihood of fine-tuning given LID is also 1 in a million. Well, in that case, the likelihood of fine-tuning given bare design can be no smaller than 1 part in 10 to the 11th power, those 2 1 in a millions multiplied. It would just be those 2 previously mentioned probabilities multiplied together. So, but then you have to realize 1 part in 10 to the 11th is small, to be sure. But if we've already granted the claim that the probability of fine-tuning given bare non-design is outrageously small, 1 part in 10 to the 136, if we follow Luke Barnes, then it will follow that fine-tuning is far, far more likely given bare design than given bare non-design. So for that reason, premise 2 of the anti-design argument is false. Okay, so that's the general point. But why grant those 2 conditions? And here's where I think, given that first condition, that the prior probability of life-inclined designers is non-negligible, I actually think we have 2 powerful reasons to affirm that, but let me just supply one, because that will raise all sorts of questions. So here it is. We can ground the likelihoods here, or the prior probabilities and resultant likelihoods, based on frequency data from known agents. That is to say, from human beings. So in preparation for this discussion, I read a very fine paper by Lydia McGrew, where she makes this argument. When we attempt to discern the likelihood that agents in general, whether known or unknown, would design a life-permitting universe, it will obviously be relevant what the data indicates about the inclination of known agents. And here, it's clear enough that known agents are inclined towards relevant ends, like producing objectively valuable products, producing arenas like computer programs or simulated realities that allow for complex structures rather than monotonous or simple products. And so if we think of in this extended setting from ones we're familiar with, it's not at all unlikely that, say, we're human beings designing universes, simulated or otherwise. They would prefer universes that allow for life. They're just so much more interesting and valuable to us than barren, otherwise boring universes. And so we have data about the frequency of life-permitting, or at least complex products of intelligent agency among known agents. And so then, via a simple inductive inference from the known to the unknown, from all observed A's to all A's in general, we can infer that the same frequency will hold of agents in general, whether known or unknown. So then, in the absence of an argument for thinking that a cosmic agent would not match those frequencies, would not be inclined to create life-permitting conditions to the same degree, we are justified in extending our inductive inference to include them. And here the argument is very abstract, but to use Lydia McGrew's illustration, we can imagine finding what appears to be, anyway, what resembles a Volkswagen orbiting a nearby star as we peer through our powerful telescopes. Now, if we did that, we would infer that a non-human agent was responsible for that occurrence. And why? Well, because the likelihood of products like that, given known agents, is not terribly unlikely. And so we infer via induction to the same non negligible likelihood given agents in general, which will then apply to non human or alien agents. And so it's this kind of inductive inference from frequencies among known agents that allows us to even possibly infer the existence of ancient civilizations or alien civilizations, or even more provocatively, to demonic or angelic beings. I mean, I take it that there's possible evidence for demonic activity, for example, even if we had no knowledge about the independent motivations or goals of demons, for instance. We could still have possible evidence such that were we to have it, like chairs flying around and writing on the wall appearing in blood saying I am a demon or something like that, then we would have evidence for demons. And the basis for that likely description would be a very general and abstract inference from frequencies of relevantly similar events among known agents. One more illustration, which I think is particularly pertinent. Here is what Donahue 2024, which is me in a paper called Awesome Minimally Theistic Evidence, would have to imply. So that is evidence that would clearly warrant inference to a version of the Bayer design hypothesis. Let's say that we found the digits of pi woven into the temperature fluctuations of the cosmic microwave background radiation. Okay, this is a relic of about 400,000 years after the Big Bang, when the universe went from opaque to transparent. So what one scientific publication actually attempted to do was analyze the temperature fluctuations of the cosmic microwave background to see if there was any meaningful pattern within it when translated to binary code. Now, they didn't find anything, but imagine they found the first 1,000 digits of pi woven into it. I take it that that would be pretty strong evidence for some sort of cosmic designer. But of course, the only data we have that could undergird that crucial likelihood would just be the frequency of known agents of human beings producing patterns like that. Known agents produce products featuring mathematically significant arrangements with a non-negligible frequency, and thus we extrapolate to agents in general, and thus we ground the crucial likelihood to a cosmic designer. And so I think, barring something I'm not seeing, we can do roughly the same thing for Bayer design in this case. We can grant a much higher prior probability to life-inclined designers because we ourselves would be life inclined. And there's no symmetrical way of doing that for other hypotheses. It seems to me that if we can do that in the case of awesome minimally theistic evidence, we can do that in the case of fine tuning. And so that's one reason to accept that first condition. The second condition, that fine tuning would have a non-negligible likelihood given life inclined designers, I think just follows by definition.
Let's just accept that.
So
we need to get
yeah, so I think we can accept that. So there you go. That's my reason for rejecting premise one from Lydia McGrew. This is my first time like putting the argument out there, so we'll see how it goes.
No, very good. Yeah, this was actually short answer. I don't think it works, and I think there's a clear symmetry breaker between the cases. But this was one of the sort of sticking points that I had with Matthew when I talked to him. Although it was surprising to me because I didn't expect it to be. But anyway, yeah. So and I, for context, that Luke Barnes also has this sort of star rating case that he's talked about. Like, imagine that the stars arranged in the night sky to form the verses of the Gospel of John, night after night, right?
Yes.
And it's sort of presented as a challenge for opponents to fine-tuning it. It's like, if your objection to the fine-tuning argument rules out that would be evidence for a designer,
yes,
then your objection has to be wrong, right? Because clearly that would be
right.
Good evidence, at least for some sort of powerful agent. It would be quite strong evidence for that.
Right.
And your example with pi in the whatever it was is sort of similar to that.
Yeah, very similar. Very similar.
Yeah. Now, I do think that that evidence, we can use that, and we can use a generalization. We can update on facts about what humans tend to do, or what sort of things tend to produce those things. In the case of humans, to more general fact about designers, and then update on the fact that there's those sorts of arrangements, say the digits of pi or the stars arranged a certain way, and that is more or less legitimate. There's some potential dependence between the data there that we might want to account for, but I think the updating there is perfectly fine generally. Where the reason I don't think it's fine in the fine-tuning case is that we're going to have, I think, just a clear case of double counting, because the data in the first case is based in part on our observation that there are life, life, that there's life like us that does certain sorts of things. And
Mhm.
even if you frame the generalization in a way where we're not saying that it's living things that do this, it's just designers that have this sort of tendency,
Mhm.
that still is part of your background. And it's fine to update on that. You can update on the fact that designers tend to do this, and where L is now part of your background. But you can't gain further confirmation of some hypothesis by then updating on L, right? Because it's already part of your
Mhm.
background. Um, so, I mean, this point could be put a little bit more technically, but that's the basic worry here, is that there's a sort of double counting here. And note that you don't get the same double counting, or at least not remotely to the same degree, in the case of the star writing or the digit pi and the constants. And also, another slightly more technical point, which is that even if it's not a matter of double counting, there is, I think, what we might call sort of covert background dependence, where the data in the first case that we're updating on to reach our generalization is not independent of, conditional on the same hypothesis, the other data. So, like, um, in fact, the fact probably most, or at least a significant portion of the worlds at which the generalization is true, that designers tend to do this or that, L is also true. And so you can't ignore that when doing the sequential updating. But that is a sort of less serious concern, because you might still get decent confirmation by updating the second time. Um, in the case where L is not part of our background, you don't get any further confirmation, because you're updating on something that was already part of your background. But I don't know. Does that make sense? I'm going to explain this further
Go.
if necessary.
No, I think I know what you're getting at, but expand on that first point about double
Yeah.
counting for my benefit and for the audience.
Yeah. Um, I mean, the idea really is that if you can, it's perfectly fine to update on multiple pieces of data, right? This is what we do all the time. Um,
Mhm.
so you can imagine sequentially updating on A and B and C and D. But if it turned out that A, like the first thing that you update on, um, included or entailed or was based on some observation which entailed, say, L, then it's going to
The
turn
like
out that
permitting
L,
conditions.
yeah, but
Yes.
or more generally, we can think of L to just stand for anything, right? Just to make a more general point about the double counting.
Sure.
Uh, then L is effectively, now you're effectively also updating on L. It's part of your um, evidence that when you go to update again on something else, it's then part of your background, right? And if something is part of your background and then you update on it again, it can't provide any further confirmation for you, because
Yes.
it's already, you're
Yes.
not updating on anything new, right? You
Yes.
just already have it in your evidence. You've already incorporated it when you updated the first time. Um, and so the thought there is that, yeah, I mean, in the case of our evidence regarding what designers tend to do, um, based on observations of people and so on, that was based on something that assumes that L is now essentially part of our background. Um, even if, and it doesn't, and this can be shown by example, but it doesn't help if you say, well, hang on, as I said sort of briefly already, um, the data that the generalization that I have here is not that there's living things that tend to do this. It's just that, yeah, designers tend to do this. And that's a more generic fact, which doesn't entail that L, right? Because of course there could be designers that, even if L is not the case. Uh,
Mhm.
and that is what I'm saying briefly. That doesn't help. It would help if the way we came to this data was not by observing living things and so on, because it's not a legitimate move, probabilistically, to take data which assumes that L, uh, abstract away from it to a more general fact which does not assume that L, and then use that to update in a way where L is not part of our background. That's a sort of
Mhm.
circularity, bootstrapping, double counting that can be
Mm.
covert, but that's the basic idea.
Yeah. Well, this objection occurred to me, and I didn't know if it would occur to you, because I
Yeah,
don't actually think this objection is cogent ultimately, because here's my way of framing it, and then I'm going to repeat it back to you and tell me if I've understood it correctly. It's
sure.
that in any Bayesian inference, we have a set of given information, background evidence, which is just fixed as given, that we hold constant when evaluating any hypothesis. Now, if
Sure.
we include in that background as given this data that I've appealed to about frequencies of certain ends or aims of designers in general in the background. Well, that fact by itself will entail that the universe is life permitting, because the evidence here that's taken as given is observations of human beings and their preferences.
Right.
And so that fact by itself is going to entail that the universe is life permitting. And so if we include that as given, then the question we're asking is essentially, given that the universe is life permitting, what is the likelihood that under naturalism, the universe would be life permitting, or bare design, or bare non design? Well, the answer is just going to be one in every single case. And that's no help to anybody. So is that a version of what you're getting at?
Yeah, essentially, right. The thought is that once you've updated on this data, it's now part of your background that L is the case. And so you don't get further confirmation for design or non-design or whatever based on then updating on the fact that L. I mean, that's already part of your background. It's already part of your data.
Yeah.
Yeah.
So my response, which might prove unsatisfying, is that I think that this implication and this problem is due to the inadequacy of our probabilistic framework in this very abstract and unusual circumstance. I mean, in almost no other situation where we're considering the evidential impact, the impact of a certain piece of evidence, are we forced to consider ourselves as not existing, or as potentially there being no human beings, or even ourselves as not existing. And it's just not at all clear how to proceed, how to apply these probabilistic principles in that kind of setting. So, for instance, to appeal to some intuition pumps, I think it's at least epistemically possible that we could reframe the awesome minimally theistic evidence so that it was actually conditions required for the existence of life that ended up spelling out the digits of pi. And in a case like that, it just seems obvious to me that we should still infer some sort of cosmic intelligence, and it would probably have to be based on this sort of inductive inference I've given. Now, will that violate the Bayesian approach to probability theory? Yes. But I think that just points to an inadequacy of the Bayesian methodology in this setting. Now, of course, we've assumed that methodology in articulating the fine-tuning argument. And so it's going to raise serious questions, but I think we just don't really know how to proceed in the correct, rational way in a situation like this cosmic context where we have to consider ourselves as not existing. And I would just appeal to, as the intuition pup, that example of awesome minimally theistic evidence where it's connected to the conditions for life's obtaining in the universe. Yes, technically we can't update on it for the reasons you've sketched, and yet it seems clear that we can in a broader sense of can. Now, I don't want to
sort of agree.
Yeah, so I don't want to cut off the branch upon which I'm sitting as a fine-tuning advocate, right? Like undermining the Bayesian approach to probability theory as a way of framing our credence and beliefs and evidence. But I think it points to an inadequacy thereof. So that it's not a powerful response to the objection to just go, well, we can see it's probably wrong, but I don't know why. But it's a point that's bothered me for some time, and that's why I've refrained from articulating Lydia's argument. But I do incline to think that that's probably the most rational response, is to say that we are in need of further analysis of the right probabilistic principles in this very unique situation.
Yeah, no, this is a very interesting point, and it's also interesting because if I understand your example or modification there correctly, Matthew basically gave me the same exact thing in our discussion. His example was something like Matthew Edestein, yeah. He said something like, well, suppose, like, we were discussing the star rating case, right, and the double counting. Like the point was that I was on my view that the inference to agency from the star rating case doesn't involve double counting. But what if it turns out that the how did it go? If it turned out that the initial observation regarding what designers tend to do or whatever like that, what sort of things tend to produce, complex writing, and what sort of things designers tend to do in terms of communication and so on, especially when they correlate with existing writing. What if it turned out that that entailed, or at least made very likely, that the stars would be arranged in that way? Or I think the example was something like, what if the fact that L entailed that the stars were arranged that way? Weirdly, for example, maybe the only way to have a life-pending universe is to have physical parameters which like necessarily result in those sorts of configurations. I mean, it's a sort of extreme example, but like just to be clear, do you understand the case? I think it's supposed to be sort of similar here. The idea is that the
I think
initial
it's what I
observation.
was saying of
Yeah.
like we can imagine that let's say that we do have this discovery of the digits of pi woven into temperature fluctuations of the cosmic microwave background. But let's also say that scientists find out that that temperature distribution amongst the cosmic microwave background corresponds to the life permitting range. That actually, if the density perturbations of the cosmic microwave background were different and therefore the temperature were different, life couldn't evolve in the universe. So there's fine tuning here. Then those two would align, right? The
Yeah.
mathematically significant arrangement and also fine tuning. Well, here I think we still have a good inference to a designer, even given these Bayesian problems of double counting or of taking as given
Yeah.
data that entails fine tuning, so on and so forth.
Yeah. Yeah. And my thought on this was, and I'm not sure that I've fully worked this out, but my thinking about this is that it should be evidence for design, but it still also would be double counting if we updated again on the fact that there's this arrangement. And so, okay, two things to note. One is that I think the point about double counting just has to be correct, right? If it's part of our background, if we're updating on something which was based on the data in question, you're not going to get further confirmation if you update on it again. That just has to, that just sort
Mm-hmm.
of has to be right. However, that's not to say that when you update the first time, you might get strong confirmation for a theory. It depends on what sort of data you have relevant to that update. And my
Mm-hmm.
thinking is that in the case of uh, in these sort of weird examples where the distribution in the CMB, whatever,
Mm-hmm.
or the arrangement of the stars is like required for there to be life permitting conditions, or for there to be life in the first place, or for there to be the whatever data we initially updated on. I would want to say, yeah, but like, look, when we first update on our fact, our evidence about, um, well, we have evidence about how things like this tend to get produced, like arrangements of symbols like this, especially when they correlate with existing ones, and evidence about what sort of designers tend to do versus non-designers tend to do with respect to those sorts of effects. Although I think the first evidence is much stronger, but whatever, that's not important here. And it turns out that that evidence that we have also entails that there be life-permitting conditions, and so also entails that there would be um, that sort of configuration in the CMB or the configuration in the stars. Well, it's like saying, well, when we update the first time, I have something both which entails that um, that it's likely given the uh, sorry uh, the, it's these sort of things tend to be the result of design, and that these sort of things would result, right? It's a matter of consequence there. And I think it's right to say, although I'd have to work out this more carefully, that when we update on that first time in the star writing or the cosmic microwave background radiation writing, that we get decent confirmation for design. But you can't get something similar from the first update in the case of uh, fine tuning.
Mm-hmm.
And I think my constraints sort of lead to that conclusion, but we don't get something similar in this case. But I'd have to work at that a bit more carefully
Well,
to have a more strong conclusion there.
I think, I mean, how would you ground the inference to design in this exotic case of the cosmic microwave background spelling out the digits of pi, but that also is one of the conditions for life to obtain? Because your objection would apply just as well here, that we could not appeal to frequency data to ground the relevant likelihood, because if we did, it would follow automatically that the universe is life permitting, and therefore
Well,
the probability would just be one on any given hypothesis. So it seems to me that if your objection is cogent, we simply could not make the inference here to design, but that seems wrong, and therefore that gives us reason to reject the cogency of the objection.
it's not. We have to be a little bit careful, right? Because it's like um, we can update on this data, right? Um, my reply is just that we don't get additional confirmation on the second update if the second update is on data that's already implicit in the first one. And it might turn out that on the first update we get confirmation or decent confirmation of design in this case, even though we don't get it at least to the same degree in the standard fine tuning case. And I think there's some reasons to think this. Like part of let me give sort of analogy, I think if we had strong evidence about what sort of things tend to produce, um, like the arrangements we find in the universe, say, um, well, I mean, I'm inclined to think that if we just had something like we have evidence that constants arranged this way are almost certainly or very typically the result of design. Um, and we're using the fact that L to, obviously the fact that L is going to infect our prior there and infect our data that which we're updating. It seems to me that it's still going to provide us further confirmation. It's not that we can update twice. We can't update on that and then on the fact that L, but the initial update still is going to give us some confirmation in favor of design. This is something I have to work through a little bit more
Mm.
carefully, but the
Mm.
idea, the basic idea is that we are going to get some confirmation in favor of design based on the data in question, but it's going to be entirely from the initial update. You're not going to get anything
The
further
initial
from
update upon what?
the initial update is just the uh, observation about what sort of things designers tend to do, or what sort of, um,
Hmm.
uh, and more strongly though, how these sort of things tend to get produced. It's sort of the other way, um, and that since that entails the fact that there's on this contrived example this sort of arrangement in the CMB or this sort of arrangement in the stars, that's then part of our background, and you're not going to get any further confirmation for design or agency by then updating on the arrangement of stars or CMB. Anyway, I think,
Right. But I
yeah.
think my objection would then just be that that's wrong. I mean, that you clearly are missing powerful evidence for a cosmic designer if you say that the discovery of this mathematically significant temperature fluctuation is no further evidence for a designer. Because updating purely, like, abstract away from that, let's forget the mathematical arrangement, and we're just updating on certain preferences of known designers. Well, I don't see how that's any sort of evidence for design over not design, because
Well,
this is the first step of the updating. We're not including
yeah.
these significant discoveries. We're just saying
No,
what's the likelihood of these certain preferences given design and then given not design. I mean, the preferences alone I don't think are any sort of powerful evidence anyway for one over the other.
no, the thought is that it would be because the you say that we're not updating on the arrangement in the stars or the CMB, but actually we are because it's a consequence of the initial data that would be the case,
Oh, okay,
right?
okay, right,
So
right.
in a sense, when we update on that, we should treat it as if we're updating on both of them because they're not independent. It's like part of our evidence at that point. And I can see
Hmm.
the response is like, well, but hang on, why couldn't we say the same thing in the standard fine tuning case? And there, I'm going to appeal to, I think, I have to work it out a little bit more, but I think the disanalogy there, there's an important disanalogy there. But at this point, though, do you see the basic idea?
Yeah, I do, but if we update on them simultaneously, it's not clear to me how that works. And for that reason, I mean, yeah, it's just not clear to me what that means to update on the two at the same time, given that one entails the other.
Well, you're not, in a way, you're okay. It's
And so,
if
like,
you
why
think of
could M have any sort of added evidential impact that the preferences themselves don't have when the preferences entail M, given certain scientific theories?
well, it depends on what you mean by don't have, right? Because obviously, if it's an entailment of there being those sorts of preferences, like, given the data that we collect to support that generalization, um, then obviously you're not adding anything by then saying and also M because it's a consequence of the thing that you already updated on.
Hmm.
But it's the point is that you can't. It's sort of if we're treating the evidence like what we're updating on here, it has to incorporate the fact that there's that star rating, or at least something entails that star rating, right? It would be wrong to think, but all we're talking about, if we thought that the initial update only the only consequence of the initial update was regarding the generalized fact about what designers preferred or something like that, then I would agree. You wouldn't get. You wouldn't have something that entails or strongly predicts that there be those exact arrangements, and then you could independently update on that, or more or less independently update on that. So it wouldn't be fully independent, but whatever. Um, But no, when we update the first time, if you could, no, I mean, I would want to think about this like if we thought about the initial evidence, like how much of that, how does that constrain the sort of possibility space? Like, what does that tell us
Mm.
about where the actual world is in the background possibility space? It's not just going to tell us that, well, probably the actual world is one where um, designers, if there are any, have these sorts of preferences. No, it's going to tell us that uh, there's we're uh, in worlds where there's designers with these sorts of preferences, and there are life-permitting conditions, or there are these sorts of arrangements in the stars or the CMB. And if it turns out that that's an entailment, then it turns out that there were no other worlds that there could have been where there were where the
Uh-huh.
initial data was present. But it's still important to consider that what that does to the possibility space, and then how you would update on that. We could fill in numbers
So
here or give analogies. Or,
yeah, well, okay. So if we update on the two things simultaneously, the fact that known designers have a certain preference for mathematical elegance, and the uh, CMB, the cosmic microwave background, has this mathematically significant arrangement. Well, the first entails the second. Do we grant that?
yes.
So if we update on both of them simultaneously, they're obviously not independent. And so the
Right.
probability of both obtaining, given that relationship, will be the probability of the mathematically
Of
significant
just the
arrangement
one.
get
Yeah.
of just the mathematically significant arrangement given design over bare non-design, multiplied by the probability of our preferences given the mathematically significant arrangement and bare design over the likelihood of our preferences given the mathematically significant arrangement and bare non-design. But that fails to capture the evidential, that whole conjunction or that multiplication. It fails to capture the relevant evidential confirmation that we receive intuitively when we discover this. Because what's the likelihood of our having certain preferences given the mathematically significant arrangement? I mean, it's negligible. And then, of course, if we turn to that first ratio, then what's the likelihood of the mathematically significant arrangement given bare design over bare non-design? Well, by the nature of the case, we've excluded the preferences. And so there's just going to be nothing there. And so you would be forced to say that in the case of these mathematically significant temperature fluctuations of the cosmic microwave background, we have almost no evidence for design over non-design. But that seems to be the wrong conclusion. Have I analyzed the situation correctly?
Um, I don't. I mean, because I think it's compatible with what I'm saying that we would have a decent, in fact, maybe even very strong evidence for design over non-design in that case.
Okay.
Maybe at that point it would be more helpful to like try to fill in numbers, like as a toy
Yeah.
example, or to think of analogies. But the thought is that we would have seems right to say that we would have strong evidence for it, but the confirmation comes if we're updating sequentially in this way entirely from the first update, and we don't get any further confirmation by then updating on the fact that there's those arrangements, because that was already implicit in the initial data. But the thought is that we would still get decent confirmation for it in this case.
Well,
From
but
the
do you
first
agree
update.
with my way of construing the probabilities here? So let's just focus on the numerator
Yep.
in this the odds form of Bayes theorem. Here we're asking, what is the likelihood of us having the preferences we do and the cosmic microwave background being this mathematically significant arrangement? In order to figure out that the likelihood of both of those things obtaining, it can't just be the likelihood of either one considered as independent events, because they're not. The preferences through the theories of physics entail that the constant or the cosmic microwave background is this mathematically significant arrangement. So what that means is that the likelihood of both obtaining given bare design equals the likelihood of the mathematically significant arrangement given
Well, they're hang, but
bare design.
they're not independent, but they're not um, completely dependent, right?
Mhm. That's right. That's right. So
So
either
yeah,
way, there is a probabilistic dependence here. So what I
yeah, yeah.
think that means then is that the likelihood of both obtaining equals the likelihood of this cosmic microwave background being as it is, given bare design, in abstraction from any information about preferences, multiplied by the likelihood of those preferences obtaining, given bare non-design and the mathematically significant arrangements. But you've failed to. So that first ratio would be, as we've said, very, very small. There's no information we can appeal to ground a high likelihood. And the second one would also be very small. There's no reason to think that if the cosmic microwave background has this arrangement and there's a designer, that therefore we would have certain preferences. It's just going to be very, very small. And so we would be forced to say that the conjunction of the two together is not very likely given bare non-design. It's not that strong of evidence for bare design.
Something seems wrong there to me. I have to work through it more carefully, because I want to say on the one hand that this should be evidence for design, and it should come from this initial update. But obviously, the point about double counting seems to be unassailable. Obviously, you can't get further confirmation for something if it's already part of your background. So, yeah, I mean, I'd have to maybe think about it.
It might be helpful.
I'm not sure I'm going to get to that.
I think it would be helpful for you and I to pursue this in writing. I think. Yeah. I mean, I already wrote so much down. I think I'll take what you've said here and I'll write out my response, what I've just said, but in more careful language. And then you can look at it and see it, and then we'll go from there and see what you think.
Yeah, that would be very helpful. I know that we're running somewhat short on time. I mean, maybe we have another 20 minutes or so.
I think I've got about half an hour more, and it's 3:17. Yeah, we've been going good. I've got about 20 minutes. Go ahead.
Yeah, I did want to get to that. I said at the beginning, there's a sort of secondary argument that's not independent from this, but I want to get your thoughts on it.
Sure.
And let's see here. So I want to first ask, I want to give you two hypotheses and see how you feel about the relative priors, right? One, are they similar priors? Is one much more than the other? And so on. So I'm going to let M stand for a sort of completed theory of physics, or it doesn't even have to be a correct theory. It's just like whatever theory of physics we take to be more or less correct. And you could say it's the correct one, but it doesn't really matter. But it's going to include all the laws and the values of the constants and where applicable and so on. It's going to say everything like that. Okay. Now, and obviously M is going to entail that L, presumably the actual physics is entails that the universe which satisfies those laws is like permitting. Now, okay, I want to consider two hypotheses. D and M. So D, as before, is just design, bare design, right? But suppose it's D and M, in the sense that that's maybe a little bit of an imprecise way to state the hypothesis. But it's a hypothesis that there's a designer that made a universe according to those physics. And the second hypothesis is N and M, which says that there's a universe that exists according to those physics, but it was not designed, right? So in other words, the theories agree exactly on what the universe is like, except that one of them says it was designed and the other one says it was not designed. Does that make sense? And then the question is, how should we consider, what sort of makes sense to think about for the prior probabilities of those hypotheses? Should they be sort of similar? Should one be much higher than the other? Or do you have any sort of thoughts, or is it not so easy to think about?
I feel like one of Socrates' interlocutors. I'm about to get embarrassed. I mean, it kind of depends on what you mean by M. I mean, does M, for example, include the fact that our universe is life permitting, or fine-tuning?
It entails
discoveries of fine-tuning?
It includes, it's going to include all the facts about the specific values of the constants, all the laws, everything, whatever we think that the actual physics is like.
So don't you think then that there's no way to assess the probability of that conjunction without assessing the fine-tuning argument?
Well, you might think that, but on the other hand, you could say, and I'll get to that, because full disclosure, I am laying a bit of a trap here, but I wanted to see how you felt about this.
Well, all right. So for the sake of your trap, I'll just say, that's 50-50.
Yeah. Well, it turns, it's, the way I presented it to Matthew, I just presented the whole thing first, and then where according as a consequence of the probabilities required by the standard fine-tuning argument, it's going to turn out that the prior on the design version is much greater than the prior on the non-design one, and in fact sort of greater to the degree that you think that the fine-tuning evidence favors design. Yes. And if you go to slide 26, I kind of lay out the inference there a little bit informally, but you could work through it.
Mhm.
Uh, and it's just sort of a straightforward
Yeah.
consequence. And
Yeah.
look, I think if you share my feeling, right, that it seems to make sense to say that um, when we're comparing these theories, or the only difference between the theories is one of them posits that there's like a further cause at the beginning, some designer that made it, and the other one says that there
Mhm.
isn't that cause anyway. Maybe there's some other sort of cause, but it's not a designer anyway. Um, that the priors on those shouldn't be radically different. In fact, I would think, and I think this could be sort of independently motivated, that the non-design one should be antecedently more likely. It seems like there's a lot more uh, ways you can get. Like, imagine that the you take all the non-designer causes, well, that goes under the non-design category, and so on, stuff like that. Right? It seems to be more constrained to think of the designer one, and I don't know. I feel like, at the very least, I'm not going to think that antecedently the design one is much more likely, and that gives reason. That result for thinking about these priors, I think, supports constraints that do not that undermine the assumptions for the fine tuning argument.
Mhm.
You have to say, if you think the fine tuning argument is sound in this standard Bayesian form, that no, actually, and this is what Matthew did. He's just sort of, I think, bit the bullet on this, although he said it's just kind of obvious to him that the design hypothesis D and M is antecedently much more probable than the
Yes.
non-design one. Um, but I don't know if maybe you can comment on that and how you feel about
Yeah. Well, pat on the back to me because I was dead on in that I
that.
saw the implication.
Yeah.
I think that what is driving your intuition that this is the wrong result, that the antecedent probability of theism and our physics compared with the antecedent probability of naturalism or physics, they should be equal. I think what's driving that intuition is the wrong uh, claim that the probabilities of theism and physics and naturalism and physics are independent of one another. Whereas that's not the case if the fine tuning argument is correct. In that case,
Oh,
they are not independent. You would have to calculate the likelihood of theism uh, multiplied by the likelihood of our physics given theism in order to find that prior probability. And then you'd have to do the same thing, the likelihood of naturalism multiplied by the likelihood of our physics, or the likelihood of our physics given naturalism. And then that second ratio in either case just is the fine tuning argument. And it will
yeah.
have the result that the prior probability of the conjunction is much, much higher given design than given naturalism. I think that's the right result. And it makes sense because, and if I'm right here, then the reason you think it's the wrong result is you're thinking of them as probabilistically independent. You're like, well, that doesn't make any sense.
No.
Surely that they should have equivalent probabilities. But that's not the case because they're not probabilistically independent.
Yeah, so that's a good point, but I'm not thinking of them as probabilistically independent, especially if we're comparing, say, theism and non-design. Of course, uh, you have things which are at least somewhat dependent, right? That we suppose that theism
Mm-hmm.
at least moderately predicts L, and maybe it's really quite small, but it's not like anywhere near uh, the probability of L given um, bare non-design.
Mm-hmm.
So, of course, I'm granting that they might not be independent that way, but
Mm-hmm.
the prior is not just, as you know, a matter of the conditional probability, but also the priors. And I think if it's right to say that, look, if my theory says that God made the world as we exactly as we observe it, and your theory says, well, sorry, and your theory says, well, there's that world, but it wasn't made by God. Uh, I think the right result is actually not just that your theory is not more probable than mine. Mine is actually much more probable antecedently than yours, because there's a lot more different ways that you can have a mind satisfied than yours. Yours is much more committal and specific. It's true that the separate posits on our theories are not independent, right? Because your theistic
Mm-hmm.
hypothesis much more strongly predicts, say, that there be those physics than mine does. But because
Mm-hmm.
I think there's a even greater difference in the relative priors here on the
Of what?
theories on bare design and bare and theism. Sorry, bare
Mm.
non-design and theism. That
Mm.
even granting that dependence there, mine should have a higher prior, and at the very least, not a much lower prior that would be required. Because I don't know. I mean, like, it's like if I said, like suppose I filled in the details. Um, you know, I had a theory which posits that there's this initial, like, I don't know, particle, and what that particle does is it's like just highly disposed to, it's capable and highly disposed to generate a universe, but it doesn't count as a designer. Now, um, how would we compare the prior of that hypothesis versus design, versus the theistic hypothesis?
Hmm.
Well, I mean, maybe you think that this is a bit worse. Maybe the particle theories certain has certain complexities or whatever that the design one doesn't, and whatever. Maybe you think the design one's a bit better for certain reasons, but I don't think you're going to get, oh, it's like many orders of magnitude better. Like we're talking like antecedently, we should think that it's like, you know, 99.999% likely that the design one is versus this one, if those were the only two options.
Hmm.
No, rather that, you know, I think there's going to be somewhere in the same ballpark at least, right? But note that that's just one example of a non-design hypothesis, and we already
Hmm.
have that it's sort of in the ballpark in terms of priors. Well, if we add in all the other non-design hypotheses, then it seems to me that we're definitely in the ballpark, if not greater, in terms of priors. And that seems to me the right result, if that makes sense.
Right. I think that gets back to my point that the probability of theism and our completed physics is equal to the prior probability of theism multiplied by the probability of the physics given theism in the background. And if the prior probability of theism itself is ridiculously small, well, that can cancel out any significance then we attribute to
Right.
the probability or the likelihood of our physics given theism. And it may then get the result that the priors here of the conjunction is equal to the probability of bare non-design in our physics. Yeah. Yeah, I think that's right. That's just a point about the mathematics involved.
Yeah.
It's just that an advocate of the full Bayesian fine-tuning argument would not agree with you that the probability of theism is negligibly small.
Yeah.
Obviously,
But
you can nullify the evidential impact of any set of observations or evidence by claiming that the prior probability of theism is smaller even still. Sure, but it's going to be unmotivated unless you say something more.
yeah, no, that's good. I think, but I think I have and could say more, which is that, let me just make a more broad point that I sort of already said before. But
Mm,
look, I don't suppose again that there's some uh, that's some sort of objectively correct way to go about assigning priors and conditional probabilities like this. I mean, we
yeah.
have certain rules and constraints and so on. Obviously, we want to obey the rules of probability, and if we have some reason to prefer some measure, then we could have that. But ultimately, like, there's going to be some um, arbitrariness or imprecision, and what I'm getting at here is sort of thinking about particular cases, right? If we're just comparing, well, what do we think about, like, if I just had no, before updating on any fact about what the universe is like, comparing these two hypotheses, the let's say the particle case versus the theism case, um, what's a sort of, can I say anything about sort of reasonable constraint on the relative priors?
Mm,
I think I can, right? I think, it turns out that you say my the particle theory, or as I say, there's a particle that's somewhat capable and disposed to produce a universe with those physical parameters. Yeah, the two aspects of that theory are not independent in the same way that they're not independent on theism. But the point is that it seems reasonable to think that to assign not wildly different priors on those hypotheses, not so wildly different to the extent that, like, the design one is like 50 orders of magnitude more probable antecedently, right? Maybe we think it's somewhat more probable, not like 50 orders of magnitude or something like that. That would be required if we think that the standard fine-tuning argument has the
mhm,
confirmatory power that it does. Um, and if we think about that, like, if that seems right, then that's going to put a constraint on sort of other probability assignments in the vicinity. And the best I can do is, like, well, I want to consider a bunch of different cases. I also might want to
mm,
consider certain methods and heuristics for going about assigning priors in the first place. I said something about this in my discussion with Ailstein, but we don't have time to get into that now.
mm,
Because one of the main objections I have to the that we could have gotten into, but maybe it would be good for another time, is considerations regarding simplicity. People will say things like, "Look, there, the simplicity is another reason of the certain design hypotheses is another reason to make the sort of inference that you gave, where it doesn't rely on observations about what actual designers do. It just relies on this sort of theoretical comparison to like, oh, this certain design hypotheses
Right.
are relatively simple, and so it comprise a larger portion of the background possibility space, and so on, therefore, etc. Um, I have things to say about that, but my approach to simplicity is going to be a little bit different, but I can't get into that now. But that's another sort of relevant data point for thinking about how to assign priors and conditional probabilities for the relevant um,
Yeah.
hypotheses. And I think, like, if we take all these things together, like this case, a bunch of like other cases we can construct, and just general
Mm.
heuristics, I think that make more sense for coming to assigning priors and conditional probabilities. I think the best result is going to be one that accords with the sort of constraints that I gave in my argument, and not ones that would be in support of the fine tuning argument. Now, I think, of course, that's a defeasible case. Maybe I'm wrong. Maybe I made some mistake. Maybe there's stronger considerations to the contrary. But this is like, that's sort of where I'm at this point, anyway.
Mm.
Um,
Yeah, I think that you're hitting the nail on the head. The really
yeah,
crucial issue here, separating us, is or what will determine who is right here is the prior probability of theism itself, and
yeah,
that's a tough issue to assess. I'm working on 2 papers that are at various points of development, looking at different angles of this question about what's the prior probability of theism. Is theism a simple hypothesis in a way that's relevant to its intrinsic probability or prior probability? I don't have a knockdown argument either way, and my mind isn't settled on it because the issues are subtle and complex,
hmm,
and we're kind of out of time to plumb the depths of that conversation. But I think
yeah,
we should just continue speaking because it's complicated. If theism has a negligibly small probability, then I think you're right that the fine tuning argument fails to get off the ground. It would imply that the prior probabilities of the conjunction here is wildly different from what it actually is, so on and so forth. Or if it has a vanishingly small prior probability, then the evidential significance of fine tuning, just you can get to that a significant conclusion more simply just by saying it's just canceled out. It's no longer that significant because the probability of theism itself, say, might be less than 1 part in 10 to the 136th. And of course, it is the burden of proof of the fine tuning advocate to show that the probability is higher than that. It's not your burden to show that it's lower. So I accept that, but I think those interesting questions we'll just have to leave for another time.
yeah, very good. Yeah, I don't know if you want to leave any closing remarks on this, or if you want to cover something else very quickly. But
No, just I thank you for. I know that you're the one recording on this platform because of technical difficulties on my end, but thank you for coming on the channel today. I love conversations like this, so this is fascinating, and I appreciate it. And I think I would like to write something up in response to you, and I think
yeah,
that would get a better way of getting at the subtleties involved here. And who knows? I mean, maybe something publishable will come out of this. I mean, I think that the arguments you raise are sophisticated, and I don't see any reason to think that an interaction with them couldn't be published. So who knows? I
yeah,
mean, no pressure, but I think at least a written conversation about these issues would be totally worthwhile.
yeah. And thanks so much for having me on. I have
Mhm.
myself thought about, because actually it's sort of weird. Uh, have I'm more or less familiar with the literature, and I don't think there's really anything that's made in the literature
Not
the
like
same point
this,
that I have. Not like this. Um, and maybe that's because I'm missing something, or maybe we're both missing something on
right?
this. But I think it is something worth exploring, or at least if it's wrong, it's not obviously wrong. And I think it's probably I think it's a good point.
Yes.
But yeah,
I think not obviously wrong is the only bar that you have to meet. I mean, all sorts of mutually
yeah,
incompatible conclusions are published every day. So it's a good argument, and I'd like to think about it more. So
appreciate it.
thank you, Troy.
Yeah. All right. Thanks, Miles.